Hello, this is Mr. Huber. In this lesson, we're going to learn about solving inequalities that involve multiplication and division. Now, if you recall, when we're graphing an inequality on a number line, we're representing all the points that are solutions for that inequality. For instance, if we see here the graph of x is less than 3, so at 3 I have an open circle because it's less than. We do not include 3, right? Open circle for less than or greater without the equal to. And less than, numbers are less on the number lines we move to the left. Over here, if it was greater than or equal to -1, so we have a closed dot filled in because we have the equal to as part of our inequality, and then numbers that are greater than 1, -1 to the right. So keep in mind what a graph of an inequality looks like and how we solve an inequality, just like an equation, by isolating the variable using inverse operations. So we're going to see what that looks like with some inequalities involving multiplication and division. So if we're going to solve this inequality, we want to approach it like we would if it was an equal sign in there, 28 equals 7x. We'd want to divide by 7 because the inverse of 7 times x is dividing by 7. That would cancel out and make it a 1x, which is what we want. And 28 divided by 7 would be 4. You could rewrite that with the variable on the left side if you'd like, switching the whole thing around if it makes it easier to recognize what the graph might look like. And so when we graph this, okay, if that's 0, 1, 2, 3, 4, there, we're going to have an open circle at the 4 because we don't have the equal to, open circle, and we want numbers that are less than 4, so we're going to go to the left on our number line. And we could check this. We could plug in some numbers, not exact, but we could plug in some number that's part of our graph, like 0, for instance. If I put a 0 in here, 7 times 0 would be 0. I'd get 28 is greater than 0, which is true. So that would show that that's a correct solution, and we have an idea, at least, that it looks like our graph might match and our solution might be correct. In number 2 here, we have m over 5. So how do we solve m over 5? Well, dividing by 5, the inverse of that is multiplying by 5. And we have to do the same thing on the other side of the equal sign. Now we'll get m is greater than or equal to -5. Right? So we have -1 times 5, which is -5. And when we go to graph that on our number line, okay, that's going to be 0, 1, 2, 3, 4, 5. That's -5 right there. And so at -5, we're going to have a filled in dot. And greater than -5, so that'd be numbers to the right of that on the number line. So solving the inequality, we perform the inverse operation to isolate the variable and then recognize how we can graph that and represent those solutions on a number line. When we're solving with multiplication and division, there is one major difference between inequalities and equations. Okay? A major difference. When you divide or multiply on both sides of the inequality by a negative number, okay, when it's a negative number that you're performing the operation on both sides with, you have to reverse the direction of the inequality. So a less than becomes a greater than would become a less than when you multiply on both sides by a negative or divide on both sides of the inequality by a negative. Let's see what that looks like with some examples here. So -8 times w, I would need to divide by -8. Divide by -8. So here, since I'm dividing by a negative on both sides, okay, it's not going to change the calculations, right? This is going to cancel and give us a w. On the right side, we're going to have a -2, and my less than or equal to, though, becomes a greater than or equal to. Okay? So the w by itself, which is what we want, the less than or equal to becomes a greater than or equal to because we divided by a negative on both sides, and 16 divided by -8 would be -2. And then we graph this on a number line just like we would any other time. That doesn't change anything. So we have 0, -1, -2, so that's -2. We're going to have a closed dot on -2 and greater than, so we're going to have an arrow going to the right. All right, if we had not switched the inequality, so let's say we had left this as a less than or equal to, we graph numbers to this side on the number line. Let's like say -3. Okay, if I put a -3, if I said w is -3 and I plugged it in here, I'd have -8 times -3 is less than or equal to 16. That would give me 24 is less than or equal to 16. That's not true. And I would know then that -3 is not a solution if I had my graph going this direction. So I'm going to go back and say, oh, I forgot to switch the inequality. So that's a way you can check those things and make sure you have signs correct, that your inequality is going the right way, that you've graphed it the right way on the number line. So that's a good way to check some of those things when you solve your inequality. Plug a number back in that you think will work, maybe one that won't work, and just check that it looks like your answer is accurate. Okay, so now we look at number 4. -5 is less than -y over 3. Since we're dividing by 3, we're going to want to multiply by 3 on both sides. And since it's a negative, we want to multiply by negative. So we have a negative times negative. That would give us a positive on the right side, which we want. We want a positive y. On the other side of the inequality, we're going to multiply by negative 3, just like we would if it was an equation. And so when those cancel here, we're going to have y, and then our inequality needs to get switched because we divided, or multiplied, in this case, by a negative. Okay, when we divide by a negative on both sides or multiply by a negative on both sides, we switch the direction of the inequality. So now we have 15 is greater than y. If you want to rewrite that as y is less than 15, that's fine. You don't have to. Okay, but it can sometimes help with your graphing, so you know which way your graph will go on your number line. So now we're going to have an open circle at 15, and y is less than 15. So we're going to have numbers to the left of that on the number line. Okay, y is on the less than side. It's on the smaller side of the inequality. The 15 is bigger than y. So 15 is bigger than all these solutions. It would be our values for y. Remember, when you multiply or divide by a negative on both sides, switch the direction of the inequality. Something important to look for when we're solving inequalities versus solving equations. All right. In number 5 here, again, you should be solving these and seeing how you're doing on them. So we're going to multiply by 6 on both sides. And that cancels out. We're going to have x and then negative 66. We do not switch the inequality here. Don't just start switching everything because we see that that's something we might have to do. And because there's a negative over here, that's fine. It's what we're doing on both sides of the inequality. We are multiplying by a 6 on both sides. That's a positive number, so we don't have to switch our inequality. It doesn't have to do with this negative 11. It has to do with what we do to solve the inequality. The inverse operation that we are performing is multiplying by a positive 6. So since we're multiplying by positive 6 on both sides, we don't have to switch the direction of the inequality. And then we just have to graph it. So when we graph this on our number line, okay, that's going to be 0. We'll go negative 20, negative 40, negative 60. So we go by 20s there to make it a little easier. We're not going to put 66 little markings on our scale. And so negative 66, right, so we'll put it right about there, negative 66, and x is greater than, so we'll have our arrow going to the right of negative 66. All right, in number 6 now, we have negative 1.5h is greater than or equal to negative 7.5. So let's solve that by dividing by negative 1.5. Divide by negative 1.5. Cancels out, we get h less than or equal to 5. Okay, less than or equal to because we divided by a negative 1.5 on both sides. Since the operation we performed was dividing by a negative on both sides, we have to switch the direction of that inequality. And so now when we graph this on our number line, okay, we have 0, 1, 2, 3, 4, 5, okay? And we're going to have a closed dot there because it has the equal to and less than, so our arrow going to the left, right? So solve an inequality by isolating the variable, getting it by itself using those inverse operations. And the key to remember with the multiplication division is when we're doing a multiplication or division on both sides by a negative, switch the direction of that inequality. All right. Little maximum here, a greater than in this case, greater than 400. Who was the first rookie to throw for more than 400 yards in his NFL debut? The first rookie to throw for more than 400, so that'd be yards greater than 400. This gentleman right here, Cam Newton. Cam Newton, who won the Heisman Trophy and the national championship as a junior at Auburn University in 2011, and then was selected number 1 overall by the Carolina Panthers in the 2011 draft. His debut for the Panthers on September 11, 2011, he threw for 422 yards and 2 touchdowns. He also ran for 18 yards and another touchdown. So he was the first NFL rookie to throw for more than 400 yards in his debut game. Cam Newton. All right, let's see how we can apply some inequalities. Not passing yardage from Cam Newton, but another example here. A pilot planning to take 80 hours of flight training to get that license. He saved $6,000 for training. What are the possible hourly rates he can afford? So the way we could figure this out, right? How much he's spending would be 80 hours times X dollars per hour. That would be the rate, right? The rate that he's going to pay would be how many dollars per hour times how many hours would give us our total of $6,000, right? So we have 80x equals 6,000. But we don't want to be equal to 6,000 because he doesn't have to spend all his money. So this is where this becomes an inequality. So now we could make that a less than or equal to 6,000 because he could spend 5,000, that'd be fine. Okay, so it's possible hourly rates. He doesn't have to pay the maximum. Maybe he can find a better deal. So how would we solve this? We'd divide by 80 on both sides, right? So 80 hours times the amount he spends per hour would give us our total. And we want to make sure that total doesn't go over the amount of money that's been saved up. So we can divide by 80 on both sides to find out that x equals 75, or is less than or equal to, 75. So he could pay up to $75 per hour. There's the possible rates that he could afford. Okay, up to 75. He could pay $65 an hour. He could pay $74 an hour. He could pay $75 an hour. He can't pay more than that because he wouldn't have enough money because he only saved $6,000 so far. So it gives us the possible hourly rates that he could afford for those $6,000 to get 80 hours of training. All right, let's try another example here. You have a folder that can hold 200 megabytes of data. You have photos that reach 2.5 megs. How many photos can you store in the folder? So again, we're going to have 2.5 per folder, or per image, per photo. All right. That's our rate. And we have X photos, some number of photos, and we want to make sure that is less than or equal to 200 gigabytes. Right? So similar to the last problem, right? We take our rate here, right, times the number of hours. So 80 hours times so many dollars per hour, right? The hours here would cancel. If we're looking at unit analysis, the hours would cancel. We're left with just dollars, which is what we want for our answer there. So in this one, we have 2.5 megs per photo times X photos. We're going to end up with a total number of megabytes that we could hold. So we're going to have 2.5x less than or equal to 200. So then we could divide on both sides by 2.5 because we're trying to isolate the variable. So we're not dividing by negatives or anything. We don't have to worry about switching any inequalities. We divide by 2.5 on both sides. We have x is less than or equal to 80. So we can hold up to 80 photos that are that size. All right? We could have 70 in there. It's not saying we have to fill the folder, just like before we didn't have to spend the $6,000. So we're going to set up an inequality there where we can take a rate times some amount, and it gives us a total. Right? And in these cases, then we can divide on both sides, and we can find out the maximum dollars per hour we can spend on training. We could find the maximum number of photos that we can hold in that folder, and that's where you can use an inequality in a real-world scenario. So solving an inequality and graphing an inequality, not different from what we did with addition and subtraction. Use inverse operations, graph on the number line, open circles or closed dots, know which way the arrow is going on your number line. And one of the big keys there is when you're solving with a multiplication or division by a negative on both sides, switch the direction of that inequality.